Thank you, everyone. Good evening. Happy Sunday. Hope we are all keeping well. We will pick things up from where we left um, yesterday. So essentially, we will be going back to cement our knowledge of Packer. So tonight is to do a bit of a quick summary, and then we are going to continue then continue to explore infrastructure as code more deeply. So the plan tonight is to, revise some of the things we learned yesterday, make sure we cement that knowledge, and then basically build on those foundation blocks that we've been laying, and then use that to further increase our knowledge of infrastructure as code. So for tonight, I'm just going to take us a little bit back to where we left things yesterday. So a bit of a diagram to kind of refresh our memory. So what we basically achieved yesterday was using Packer as a way to create our own Amazon machine image, which is an image based on a parent image of Linux, Amazon Linux AMI. So that serves as a foundation or the base image, which we leveraged. And then we were able to slap Nginx and Git on top of that base image to generate a new image, basically using Packer. I did mention yesterday that Packer is a tool that is specialized, specifically built for creating images of your instance, such that that image can subsequently be leveraged to spin up running virtual machines. Any virtual machine that you create is it's often based on an existing image. You could go for the default images that have been provided out of the box, or you could create your own that specifically is tuned to your need. Yesterday, we did look at using Packer to, at least in an instance, in our scenario, spinning up one with Nginx and Git installed on it. And then subsequently, we were able to create two nodes. Essentially, after we successfully create an image, creating an instance of VM of that image is something that can also be managed using code. Obviously, the Packer situation was, it's code-based, but turning your image even to a running VM can be managed via code. So instead of us going on the console to literally click and have those nodes provisioned, we can use another utility that is specifically meant for that to create a VM of the image that is provided. So one of the tools that is commonly used is Terraform, and I'm going to come to that in a bit. I want us to kind of understand the flow of things. So Packer for image and some other tools, for example, Terraform to spin up your VM based on an image. So it might be an interview question. Packer is mainly for creating images and Terraform for creating instance of your infrastructure. Okay, so just take a step back and look at what we achieved yesterday. This is the code base that we created to spin up that Git stroke Nginx instance. So what we want to do today is I want to kind of discuss how this would be even done in a more professional way, not just stopping at where we left things yesterday, which is obviously a step up to where we were a couple of days and weeks back. Now we are writing code. Now we are using Visual Studio code platform to basically write our code. We are pushing our code to the sort of version control system, GitHub. So if you want to take things a little bit further, just a notch or two up in terms of getting close to how things will actually be done in the enterprise, I'm going to show us a little bit of what we need to do to kind of, work in an enterprise mode, if you like. So we have a code, and this code works. It's been pushed to a repository in Git. Our initial objective has been fulfilled, which is Packer to spin up AMI and basically generate an image. The only fly in the ointment, which is the only weakness we have now, is the fact that in reality, you would not be running Packer on your local machine. So in real life situation, what tend to typically happen is you're going to have a machine called something like a tool server, which is going to be based, it's going to be cloud-based. So this tool server will be the machine that will orchestrate things such as the using of Packer to create an image and having that image used. What we did yesterday was it was just me here running Packer on the local machine, and then connecting to the cloud. And connecting to the cloud. So the way this ran yesterday was me writing the code and then running on my laptop, and then the image is created. Typically, this is how it would work. I'm going to kind of show us how it should work typically. So the first thing is we have the code here. So a DevOps guy or someone that is managing a Packer code would write the code on his local machine. So that might be your developer, that might be your DevOps guy, whoever it is, will create the code on his local machine, which is something I'm going to do. So this code we already have. Okay, I'm going to say I wanted to improve a few things in this code. Just kind of play this scenario. I will have this code on my laptop updated and pushed back to a repository. So I'm just going to mimic that. So this is the code. It might be a case of, okay, we have the code and your boss is happy. You're writing the code. Let's assume we've not used the code to spin up anything. Let's assume that the code is just a work in progress. So your boss or your team lead checks this and say, okay, this is good. Or he says, all right, this is going to be our infrastructure as code repository. You are creating Packer, but we might need other things along the line, maybe Terraform and maybe some other things. It now advises you to maybe create different directory structures, maybe one for Packer, maybe potentially later one for Terraform, and then move this into a Packer repository. And then maybe when you create Terraform in future, you move your code for Terraform to Terraform repository. Essentially, it's telling you to refactor your code base. And then obviously after that, executing the code to make sure that it does what you want it to do. So I'm just going to play that scenario to show us how this will work in real life. So the code is in a repository. So what you do as a developer or as a DevOps guy managing the infrastructure is you download the code. First, you're going to be pushing back potentially into the repo. So you download the SSH, so you copy that. And then what you then do is you find your way on your machine. So I've created a location here. So I'm going to do a clone into here. Okay, I'm going to have the repo cloned, and I'm going to open Visual Studio Code here. So that's open up. Okay, let's put it here. So Visual Studio Code opens up. Okay, we go here. That's it. And then we can get into the stuff here. So this is all good. We can access the command line here. Everything looks perfect. So your boss advises you to do some refactoring and just to make sure your code is tidy, you do your README file, etc. So you then say, okay, all right, I'm gonna make things a little bit better. So you create a folder. You call this Packer. You create another folder, you call it Terraform. No, let's put that outside. So Packer folder, Terraform folder separate. You don't want to put Terraform in Packer. So they're all separate. And then you move this Packer code into Packer. So we haven't created any Terraform file yet. So we're going to create a dummy file because if you don't create a file, you will not be able to, if you push empty directory into Git, it basically ignores it. So we're just going to create a little file in here, new file. Just going to call it Terraform. Let's call it main.tf as Terraform. We've not done it. We're not going to do anything. We're just going to say, let's just say with a comment, place order for Terraform. We're going to come to Terraform later. Okay, so we'll save that. So then we'll go back to the Packer bit. Okay, so the Packer thing we've done is good. Let's see. Let me make this bigger. So we've got the code and we do Amazon Linux and what have you. So let's say, for example, we wanted to create maybe a second node. So we have the Nginx, or maybe we want to, let's look for a scenario where we would maybe create 2 VMs. So let's say we wanted to make 2 VMs. We should leave it at this. Let's create 2 VMs. So we're going to create 2 VMs. So essentially, we're going to create one for Nginx. Okay, we'll probably create one for maybe the one that's running Java. Just kind of separate them out like that. Okay, so this is the one for Nginx and Git. So the other one will be we'll put Java and Git on it as well. And that will just be a separate instance. So it's not really difficult. It will just be a continuation of this. So what you do, so as a DevOps guy, you've been asked to extend this to maybe create 2 VMs, one for Java and one for Git, one for Nginx. So we have the one for Nginx, okay? So we can probably call this the Nginx one, which you already have. We can just change the name to maybe version 2. But the Nginx one, I already created one yesterday. Let's create a V2, and this is still valid. Okay, this is still valid because we have the VM creation here, and we have the installation of the tools that we need on it. This build, that's the build name. It references this source, which is that source, and everything remains the same. Okay. So what we want to do next is we want to, source out we build the AMI, say for Nginx and Git. So we will do one for Java. So, and then it's just a repetition. So this probably will just be Java and Git, Java and Git. So it's going to be the same as well. So Nginx, we're just going to change that doesn't change. And we can call this Java Git. Let's just leave that V2, it doesn't matter by Parker. So you can see they've just changed a few things. So that changes. And then we're going to have to create a build source for that as well. So we can just copy this build and then just replicate it for the Java one. Okay, it's all the same. It's just all the same approach. So essentially, what we then do is we just basically edit this to reflect. So we do the update. So first thing we're gonna change is we'll call this Java Git AMI build, and then it's not referencing Nginx Git. In our case, it's gonna reference this one, Java Git source. So we would say that's the Java build. The source will be not Nginx build, it will be Java build. And then the installation, what it basically will install we install yum update. We don't need Nginx. So we're gonna replace that with Java installation. So I basically yum install Java 17, Amazon Corretto, and then we just install that. And then we won't need any Nginx that stuff. And all these extra ones as well, they will not be needed. So it's just Java installation and maybe Git installation as well. So the install, this is going to be install Java 17, Amazon Corretto. That's the Java you want to install. So you're install Java 17, Amazon Corretto. That's the one we need. Install that and cool. And then we can say maybe AMI build is finished. For I can just say maybe for Nginx finish for Java, something like that. So, I guess that basically covers it. I just want to I'm just trying to show us how incredibly easy it is to extend this. We have one for Git, for Nginx, another one for Java. So Java Git, Nginx Git, right? And then we're gonna have end up with two Packer images and so forth. Okay, so this is you as an engineer basically building creating that template. Okay, so one thing we can do is let's have a look here. PWD, ls. Okay. I think CD, I think I should be here, classic. Everything should be here. So my directory structures, remember that this is the repo, right? And if you go git remote -v, that's the repo there, okay? And which is this repo. But you can see my Terraform is created outside of that repo. That is a mistake. The Terraform should be inside the repository as well. So I'm going to move the Terraform folder into there so that everything is basically within that. So that when I ls, I should see the Terraform, I should see the Packer there. Okay, so we got the two there, right? Packer, Terraform. Okay, the Terraform is there, the Packer is there. All right, okay. So for me, in this case, which we are working on the Packer, we don't really have anything in Terraform yet. It's just we're just creating a placeholder here. So for the Packer one, we go into Packer. Remember, this is you working as an engineer on your laptop, which is basically you doing that. Okay, but we're going to have a bit of a twist in terms of how we do things. So the code is still being written. You're extending the code, which is all good. So what you want to do first and foremost is we want to validate that this code works. So you're not gonna, you don't want to execute it, but just want to check. So you're gonna do something like packer init dot. Just initialize your packer before you use it, and then you can say packer validate dot just to check your syntax is good. Okay, so for example, I forgot to put something here and it's all kind of a bit wishy-washy. Validation should pick it up. You can see that it's telling me that my syntax is not correct and stuff. So that's what validation does. In reality, so if you validate now again, that's all you can do when you are on your local machine if you are not inclined to execute this on your local machine. In reality, in real life situation, maybe you're working for a big company, you might not have all the authentication information that you will need to connect to a cloud platform. You know, remember we did some exports yesterday, which allowed us access to the AWS platform. In real life situation, as an organization, they might not share those credentials with you. They might just ask you, write the code and push your code into a repository, and the other team will take it from there because they don't want to be sharing security information that would allow the execution of this with sharing with everyone. In an enterprise situation, all you would do as a developer or as a DevOps guy is write the code. So when the code is written, what you then do, instead of executing and producing the image, that won't happen. It will be a different flow. Okay, the flow will now be that. So let's say this is you here. Pardon me. So let's get this together. So this is you here. We'll move it to the back a little bit. So you do your installation and what have you. All you then do is go over the internet and then you push your code into a source control system such as GitHub. So GitHub is where you push your code to. So it's cloud or internet. Let's say internet. So you push your code via the internet into GitHub, okay, because you don't have access to the platform. So the cloud platform that you want to use, let's see, that cloud platform, you don't have access to it because maybe maybe they've not shared the security information. So there's no way you're going to provision those machines because you don't have access. So this is all like shielded from you. You don't have access. You can write your code. You can basically validate the code and make sure the code works, which is what we're doing. And so this leg will not exist. The only leg you have is this leg to internet and GitHub. So the tool server, you probably don't have access to as well. So what then happens is at enterprise level, organization will they'll have a machine, maybe they will call it something like a tool server or execution node, execution node, something like that. So this machine will be responsible for executing all that you want to do on your behalf. Okay. So instead of you basically having all those exporting on the system and pushing stuff into Git, that won't happen. So it is this machine that would go and basically pull your code from GitHub and then use that code to then do what it has to do, which in this case is generating Nginx image, okay, and basically using the Amazon image. Let's see. In that case, let's take this a little bit on here. So we're gonna use Amazon image to generate Nginx, which then generate these two nodes. For the same Amazon image now, we are going to use it to generate another node. This case will be Java and Git. And then that then creates an AMI. Okay, that creates an AMI, which is this. And from this AMI, this is all node 1 Nginx, node 2 Nginx, which is what we did yesterday. Well, in this case now, we are going to use an image. From that image, we will create Nginx, which has different install, and Java, which has different install, and this will be for Java. So Java, of course, the ID will be different because we are creating a new one today. The AMI will be different because we are creating a new one today. From this AMI, then you can then spin up a Java instance, which is like that. Just going to be maybe node 1 Java. So everything will be done in a tool server. we would not be doing things on our local machine. We just, other than writing the code and pushing it back. So the code has been written, it's been validated, it looks good. It doesn't mean it's perfect because we're not executing it. So the code is there. So what we do now is we do git status and then we push stuff. So you can do on the command line. Just say git add all git status. Okay, so it's talking about untracked Terraform files. I'm gonna go back on step. I'm gonna git add that as well. If you are not really familiar with this, you can always go here and just commit everything and go. If you want to like be cool, you can add and do a command line status. Okay, you can say git diff. What is the new thing that's different? Okay, you need to commit first. Git commit -am. Refactor code and extended Packer code base, something like that. Code base, something like that. Okay, you do good, do get div. Okay, still not then. Right. Okay, so now let's leave that. So we've got these changes, and I can see we can just sync it, or you can just do push. You can sync here, you can push here. You can just push here, same thing, or you can sync, and everything kind of goes back off, right? So if we go back here, it's gonna be, it would have changed a bit because this would have been moved into a directory. Okay, and then you can see Parker, which is the new Parker file. We probably should have renamed it to that AWS Nginx Java Git, something like that. And let's do that renaming actually, just for good measure. Okay, right. This one we don't really have anything. Okay, so let's try to rename the file. Just go back here and then just do this. Rename. So this doesn't impact anything. It's just making sure we are the refactoring looks good and the name reflects what is happening. So Nginx, Git, and maybe dash Java as well. It's just that. Okay, so do Git status. Git add dot commit updated file name, updated file name. Okay, and you get push and Bob is your uncle. But that's all done now. So they should probably carry a better name now. So we go here. We go, and then we go Parker, and we have this better name. Okay. So now, and that is this end of the deal basically done. So in reality, you don't want to be running stuff on your laptop because probably you don't have credential information to do the execution to connect to your production, to your cloud platform. Maybe you do, maybe the permission you have does not actually help you, but they want to centralize how infrastructure are created on your cloud platform. This is how it typically works at an enterprise level. So what they do, and please, I don't want to confuse what I'm trying to explain here. So what they do is typically they already have had a machine that is dedicated for code execution, and they will probably call it tool server, execution server, whatever. So we don't have that now. Okay, and on your execution machine, all the binaries that it needs to do this work will be installed on the machine. And this machine does not do anything other than it's just a tool server that helps with running of code, etc. So we are not going to use Packer to create this tool server because we will assume that this machine already exists at enterprise level in the company. So we're just going to cheat and basically manually create this tool server ourselves, but we'll be subsequently use it to as our tool machine to actually tease out other machines or other artifacts we're going to need. So we will not be running things on our local machine anymore, rather than writing the code and pushing it into a repo. And we're going to be using the tool server to basically execute things on our behalf. So we're just going to quickly spin up that tool server. So just manually spin that up because it's going to be a one-off thing. So we'll create a tool server. So we're going to call it, let's just call it tool server. Okay, it's just going to be basic stuff. So the tool server is good. We'll get the master class key. We only need SSH access to it. And honestly, that is it. Okay. Tool server gets created. So the tool server gets created. Go to, yeah. Then we'll find the server. All right, so we can connect to it. So obviously, for the tool server to work, and let's connect to it. For the tool server to work and do the thing we want to ask of it, the tool server must be able to communicate with GitHub, and it must be able to use Packer to do all this magical work. So at least it needs Git installed so that it can communicate with GitHub, and it needs Packer installed. So it will be able to make use of the code we've written and use Packer to basically make that code run the code. Okay, so the assumption here is that this is the machine that is dedicated for that operation. So it will not, we're not running code directly on a machine anymore. We are actually running it on the tool server. So whatever I'm going to do now, in reality, will be a script that does it, but it makes sense for us to kind of go through that manual process. Eventually, we'll graduate to using script, but it makes sense to understand what we're going to be scripting eventually. So this is tool server. The tool server needs to communicate with GitHub or your version control system. Always remember that GitHub is not the only version control system out there. You have Bitbucket, you have Azure DevOps repo, you have even code commit on AWS, you have GitLab. There's so many. So we're just using GitHub because it's the most popular. So this is the code in GitHub. So of course, for this machine to be able to, for you to communicate with GitHub, we need to install Git on this machine. Otherwise, we will not be able to, it's not be able to download the code. So sudo yarn install git -y, and then that will get Git installed for us. One thing we're also going to need is Packer. So I'm just on this machine. So I'm going to go on here. I'm going to say ashicop Packer. So install ashicop Packer, and I'm going to, so because we would install Git, which is probably almost done. So Git is on this machine now. Git the dash version, and Git is there now. So we're gonna need Packer as well. Okay, so we're gonna install Packer on this machine. Gonna say Packer is probably not there yet, and they're gonna say I don't know Packer. Okay, so get Packer on the machine. So we got Linux is the machine, and we're using Amazon Linux. So this should be um our own option. So we copy that, and then we'll hope that this works out. So copy and and then I'm gonna paste that, and then just hope for the best. I'll say yes, and then I'll say yes, and then I'll type Packer now. Probably say Packer version, just not to type Packer, just make it Packer. I mean, it's that simple. So we got Packer, we got Git on this machine. So this machine now officially now is our tool server, this machine. So the developer, whoever will be sort of just doing the thing in this tool server, not your laptop anymore. So you go from the laptop, go to GitHub, the tool server will pick things up from there. Right. So they might then control who is able to use the tool server. Anyone can write the code, but only a few people can execute it. So the code execution, what would that look like? In our case, obviously, things are no longer happening on the laptop anymore. For execution to happen, obviously, you need to download the code. So we'll say, let's say git, let's make a directory, let's call it workspace. We're going to make a directory on this 27 mkdir workspace. This is how we're going to do all our magic, cd workspace. It's going to be the place where the magic happens. So where are we? We are in workspace. So we're going to do a clone. So this is going to be the repo where we do things. So we're going to do a clone of things. So we want to clone this repo down. So we look here, say, okay, this is the repo. And then, of course, because you are cloning it onto a tool server, which probably doesn't have its key already exchanged with GitHub. So it makes sense to clone as an HTTPS instead of SSH. Otherwise, you will have to do key exchange before SSH can work. So this is a throw, a read-only, download-only, not pushing back scenario. So this basically should suffice. So we do the HTTPS clone. We then go back to the node and then we do a git clone and then pull that down and then it's good. And we'll see this. Okay, so the first step is what we've done. So, which is the download of the repo. So if I was going to code that, okay, if I was going to code that, okay, before I'll tell us about that later. Because ultimately what we are doing here, we want to use the code to do it, but we'll see. So the manner process is make a workspace directory. We've created that workspace directory on the tool server. Then we go into that directory here. We say, where are we? We confirm we're in that directory. And then we do a clone. After doing the clone, we see this, we list. So the file, the repo is downloaded, it's cloned. So we walk into the clone, into the repo, and then we see Packer and Terraform. Good. Of course, we're interested in Packer this time, so we go in there. So this is what we've got. And then we then begin to use Packer to do all the magic. So you want to do Packer init dot, to Packer validate dot, just to make sure things are all lined up. So do Packer init dot. Okay, all right. You say Packer validate dot, validate dot. And everything is valid. And then you want to do Packer build. The Packer build dot will fail because of authentication reason, but let's check that out because it doesn't know, the Packer won't know how to get to AWS because you've not given it the credentials. But let's see that in action, build dot. And then it fails because it doesn't have the credentials, blah, 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 blah. So this is where you then basically do your export essentially. Just say, okay, this is what I'm gonna need. These are my export credentials. So in my case, I'll just do, let me just copy it and do it real quick. And then paste that. And paste that. And then also paste the default region. Should suffice. So now this is the credentials it's going to use. If you then do this now, it should just work. can see now it works because it's able to authenticate. And as we saw yesterday, it begins to create all those whatever thing that it needs to get things moving. So we're gonna, this is refresh the two server, and these are the one that Packer is creating, one for Java and one for Nginx. And those would then form our AMI that we're gonna leverage later on. The thing to bear in mind here is we are no longer doing this on a local machine. This is done on a tool server. And if we go back to our diagram just to make sure we're on track. So this is the one doing the magic now, and it is using Packer to generate those two images. So at the end of the day, we're going to have AMI. This is the VM that is spinning up to from which you would derive the AMI and AMI here. So we're going to have maybe two AMIs created for us. And okay, so it's kind of doing it at the moment. So the thing there is that whatever we're doing here, we are going to automate how it works so that we would so that we will not what's the word? We would not be manually doing this in future. So we'll see what I mean by that. I want this to complete and then I'll show us. Let me see. Okay, okay, it's okay. So the Java build this thing failed. Okay, I think there's something about the Java one that hasn't worked. So we might have missed something there. So we'll check and I'll probably do that again. So you can see now the Java one failed. The other one successful, but the Java one failed. So we'll see what's happening. So this is normal. So if you have missed something, let's look at the script. What have we missed? Java 1 shell. Yeah, correct. Yon install Java 17 Amazon. And maybe let me see. I may have just missed something there. Java 17 Amazon correct. I can use this double T, I believe. Yes. That's good. At least that helps us to see that it's not always like, given that thing, we just walk the way it should. Okay. This is, let's see, it's deleting that image and then it's terminating that image. So we are going to end up with just one instance. So let's have a look. So this is where I'll be shut down, cleaned up. We only believe our two server and our AMI probably is just that. I think this is the one that we created yesterday, by the way. And this is the one that we've just created today. So this is 16. Can you see that? That's the one. So only one succeeded, right? And then the Java one failed. So obviously then that then gets created to the developer who did the work. The DevOps guy who wrote the code, and then he goes back and then just update his code. So I'm just gonna delete all these ones because they are kind of, I think they're getting too much now. Let me just delete all these ones. Actions, they register then. I think I have to do them one by one. I think they're getting too much. So let me just do them one by one. Let me just say, yes, I'll check everything and just do that. Say action, deregister. I'm just gonna be that. Oh dear. I'm not getting the name. or I can just get the name here. It's better that way. And then say register, put the name there, register here, my, blah, blah, blah. I think I'm getting it all wrong. Please pardon me. Select deregister. Sorry, disable. So that's not it. Deregister. That's what I was looking for. So delete snapshot. I'm just gonna get rid of this. Otherwise, I might just be using too much stuff on my machine or my image, sort of AWS infrastructure. Let me get all this out so that I'm not just incurring it. By the way, so our build machine creation has failed. So if you'll find it, pardon me, please. So here, right? So we've seen that it's failed. Okay, so we're gonna do this again. So obviously to do that again, this thing goes back to developer and tell him, oh, the one that I did was not successful. You would then investigate and say, okay, right, it's correcto, and this is the mistake. Okay, it's nice double T. So we don't do, and that's the change. Let's make it real quick. And we go here, we say updated Java binary install, something like that, and just commit and push, really. Just go, that should be quick, all gone, right? And then now you come here. Okay, in that case now, all we need to do, because there's an update, so all we need to do is just pull, git pull to get the latest. And that should get, you can see now it's got something there, that's the update. And then we'll run this again, then just build. So anytime you do an update and you want to get it on another platform, and that platform already has a copy of the repo, you can just do a pull. Pull is neat, otherwise you have to delete everything and then re-clone the repo. If the repo is already cloned, you can do a pull, and that gets you an update. Otherwise, you delete the repo and then you re-clone the repo. This will all work nicely, potentially, but I want us to pay close attention to what we've done, which is a case, essentially, we created a workspace, we moved into that workspace, we did a clone. After doing the clone, we seed into Packer, and after seeding into Packer, we did Packer init, Packer validate, and then Packer build. Of course, we needed to do the export thing, and of the repo, etc. Sorry, exporting to be able to access AWS, and then we then took it up from there. So eventually we are going to automate that flow. Is that kind of a problem? Okay, no problem. Okay, the Java install now seem to be underway. I suspect as it get installed. So this is okay, Java install complete. Stop the instances, and now it's generating those AMIs. Okay, so this potentially wraps up. We're looking for AMI to be ready. Nginx AMI instance, attaching AMI, and that's the AMI for the Nginx one. And then we're gonna get one for Java also. So this is all almost done. So that is still kind of coming together. Not terminating the instances, everything should be good. Blah blah blah. And if we check here, we should have then here to refresh. And it should be there. You can see that show there now, pending available Java Gates, Java Parker, and these are good to go. So if you want to give them a name, you just add a tag in the code and say tag name equals, and that will give it like a name tag. But it's the actual name that's important. But you can create a name tag as well. You can look that up after creating a name tag. But that name is not terribly important. So this is the two server doing the work, and we've kind of changed our things flow essentially. So, and the two server probably rests now. Let's see, it's still kind of going. Okay, it's all done. So it's giving us the AMI we created. Okay, which is git AMI. That's the one there for Java, and that's the one there for Nginx. So that is this side of the deal. This side of the deal fulfilled. So we have one for Nginx, one for Java. So let's harvest the AMI, and that's the one for Nginx. Let's put it in a little diagram. So yeah, I don't think I copied it. Copy and bring it here. And then undo that. Oh, no. It's just that. That's the Nginx one. And this is the Java one. E draw, and the Java one is this one. Voila. So those are the two AMI. And then we've not done the slag. The slag. So now it is the instantiation of VMs from the images. What we're doing here, only in the last several weeks, 5, 10 classes now. This is just traditional sort of cloud DevOps. Things will move from this as we kind of go along, but it's important to cover out the basics or the base sort of knowledge that you expect to know as a rounded cloud DevOps guy. Well, things will move fast from this as we kind of go along. But I don't want a situation whereby we jump to the new fangles, but the old sort of the base knowledge that is sort of bread and butter for DevOps, we just bypass it because we want to jump into more fancy uh platform like Kubernetes, Docker, serverless, and what have you. So it's better to cover all these ones, and then we'll kind of graduate into that. So these images are now generated, right? So the leg we're now trying to work out is essentially basically creating instances of the image. Okay, we want to begin to generate instances. from the image that we've created. So instance generation now is about provisioning live system that you can use. Remember, the image are not live system, they're just like a frozen version of what you want to use. If you want to basically create live system of infrastructure that you need, one way we've seen is using the console, where you go on the console and you click away and do what you have to do. So go on the console, and this is how you would create your infrastructure. So if it was a machine that you wanted to create, you could create it and just say, as we've seen many times, you go to instances, launch instance, and then you create your instance. And that's how you create a live instance. If you're not interested in machine, let's say you're interested in database, you can go to database. And basically select the kind of database you want to create. You know, in AWS World, if you want to see them, you use RDS. That will give you all the relational database system that you have, RDS, and then you can basically click on that and then see everything that you want to see in terms of creating database. So the database you're going to create here, obviously this is a pass system because you are just going to click the database and it's ready for you. You won't have to do any installation. This is pass. And then also, this is create a database. In this case, you select the kind of database you want to create. I'm not going to do it. I'm just showing us how easy it is to do things on this platform. So let's say you were interested in, this is our relational database system. Let's say you were interested in something like Cassandra. Just type it. And then you have a Cassandra system that you probably can leverage. It's called, what is it? Cassandra, AWS Cassandra. Yes, and then, so let's search Cassandra, and then you create that, and that will create Cassandra for you. There's almost nothing you're looking for in AWS that's not there for you to just click away and use it as a pass. So instead of you creating a VM and installing it yourself, you can just find it and use it. For example, there's two called Prometheus. Is used for monitoring. Amazon has its own Prometheus that you can basically click and just use straight away. So you don't have to do any installation. It's all there, and this will be used as a pass, platform as a service. So the point here is VM is not the only infrastructure. You can create, different infrastructure depending on your need. It's all there. And obviously it's not limited to AWS platform. You will find it on Azure, Google, Oracle, list goes on. By the way, I use a platform for my company. I use Linode. Let me show you Linode. I use Linode because it's way, way cheaper than using AWS. So I will log into Linode this way. I will log in with my Google account. I'm gonna log in like that. And and I'm in Linode. And in Linode, it's almost like AWS, but this is way cheaper. So, and then you have my compute and my Linode VM. This is my VM. I have things for storage and so on. So whatever database, whatever you could do in AWS, you probably can do it, but this is way cheaper. But it doesn't have all the wells and bells and whistles that AWS has. I'm just showing this to us just to show us that, it's just the same concept around. And then many players in this space. So AWS is just one of them, and Azure and the rest. So we've been doing all that, right? I'm just going to a little diagram. So we've been kind of manually creating all these sort of machines. We spoke about what are the ingredients, the constant of machine, the CPU, the memories, and all that. But we've been creating this thing just using the console. In reality, as we've seen, even generation of images, it's encouraged to be done using code, as well as instantiation of the infrastructure you want to create. So the creation of the infrastructure themselves is encourage you're encouraged to use code rather than using console or some command line tooling. As you've seen, the advantage of using code is sort of all encompassing in the sense that with code, somebody else can write it, another person can execute it. Sort of the division of labor. There's control, so it's not just one person doing something and you never know what is done. Because that code that you wrote or you've written can be verified to make sure it's gone through the threshold of security, compliance, linting of how the code should be and all the rest of it. And also, it helps you to quickly create instances. So if something is done with code, you can always execute it and straight away you have your end product rather than clicking and trying to create 10, 15 systems, you get overwhelmed in the process. So code is the way to do things. And Packer is for image creation, but when it comes to instantiation and creation, actually bringing those things to life, maybe VM, maybe database and all the rest, there are tools for managing those. And those tools vary from platform to platform. Generally, they are called infrastructure as code tools, IaC tools, which is used to manage your infrastructure as though it's a code. So code to spin up infrastructure. So I'm going to show some of those tools that are quite ubiquitous as far as managing enterprise infrastructure is concerned. Terraform is the leader. So Terraform is the number one tool that people generally leverage to spin up infrastructure at enterprise level. The reason why Terraform is popular is because the Terraform platform allows you with a minor code change, similar syntax. You don't have to understand Azure. You need to understand Azure platform, AWS platform, but the difference in how you will write the code is not too much. So in theory, the code you're going to write to spin up things in AWS platform is not going to be totally terribly different to the code you will use to create something on Azure. So they are trying to kind of create uniformity in how you write code for any platform, such as Azure, Google, AWS. So the way the code will be structured will not be too dissimilar. It's not going to be exactly the same, but if you understand Terraform, you will be able to write code that can spin things up on AWS, Azure, Google, and all the rest of it. The popular, cloud platform. Pulumi is another popular one. Pulumi is popular because it's not as popular as Terraform, but it's popular because this is Terraform uses what we call high HCL. I can't remember what HCL means, but basically here it's more of like a domain-specific language, which is peculiar to Terraform in terms of the way Terraform code is, which we're going to see very shortly. So it doesn't come natural for developers. Unless a developer, you want to understand Terraform, you want to be using Terraform to write your code, to build your infrastructure, you would have to adapt to Azure Terraform. But Pulumi is almost like writing code in Python or Java. So the developer will find Pulumi more appealing because it's structured such a way that it will make sense to a developer. Terraform is not like that. So Pulumi is almost like a new way of doing things that is similar to properly writing code. Whereas Terraform is the most popular, but it's not something that comes natural if you're a developer and you are picking Terraform up for the first time. You will find that Pulumi will be easier for you to pick up rather than using Terraform. CloudFormation, it is AWS specific. So this is the sort of AWS way of creating infrastructure on AWS cloud. With Terraform and Pulumi, you can use it to create infrastructure on any of the cloud providers. So Terraform will create stuff on AWS, will create on Azure, will create on Google, will create on Oracle. Pulumi will do the same, but CloudFormation is AWS specific. This is vendor specific. Same for AWS CDK and Azure as well. This is basically Azure platform. And you can see these are Google platform as well. So generally, these are the most popular because you can use them to almost penetrate any cloud platform. This is number one leader, and that's next to it. But some people, because maybe they are old school, maybe they started way back, they might have stuff that they've used to create many infrastructure within their company because maybe they started with on AWS and they basically use CloudFormation for all their stuff and they probably don't want to migrate to Terraform because it's just a lot of work changing their code base to Terraform. So some companies will just keep doing what they're doing. They're gonna say, because we're not gonna move to we're not gonna move to Azure in future. We don't need to learn Terraform. We're just gonna keep using CloudFormation. You get that a lot because some people just have bias because they're on a platform. They're not moving to another platform. So why use Terraform? They're just going to stick to CloudFormation because they know it and they don't want to go through the rigor or the learning curve of getting a new tool that probably doesn't give them too much edge because they believe they probably will stay on AWS forever. Same go for Azure and all the other ones. But if you want to have learn a platform agnostic tool for your infrastructure generation, this will be the top two that you will learn. Okay, and then we can move to the third slide, which is version close to a comparison. So Terraform is declarative, ICL, Pulumi, imperative declarative. You can basically use real language I mentioned, and so forth is also kind of summarize what I just mentioned here. Okay. So we are going to learn Terraform. By all means, pick up Pulumi if you want. You can look it up. It's getting popular. By the way, let me check something. Please bear with me. Let's check on job serve and look for Pulumi. Let's see. Maybe I got the spelling right. Maybe I didn't get it right. Okay. Okay, that's there. You can see Pulumi. It says not terribly popular. Terraform. This ARM is for Azure. This is CloudFormation AWS. You can see that. So implement infrastructure as code. And if you tell them you know Terraform, obviously they're just going to give you a free pass. You're going to say, okay. We use ARM because we're Azure, or we use CloudFormation because we're AWS. If you tell them you use Terraform, they're going to give you a free pass more often than not. There's some diehard one that will say, no, we are on Azure, you have to learn ARM. Or we use CloudFormation, we don't know Terraform. I'm just telling you this because you will see it in different ways. You will 9 times out of 10, you're gonna get away, with just telling them you know Terraform. Because that will work on any platform. Pulumi is not terribly popular. So if you know Pulumi, you might be one of very few people that have taken time to learn it. So it might serve you in good stead because you might be a distinguished engineer, one of the very few that's taking time to learn Pulumi. But if you see, when I search for Pulumi, I only got one match. If I search for Terraform, I would get thousands or maybe hundreds. Terraform, let's not do that. And then you're gonna get like a lot. See, a lot. Then you can keep scrolling and scrolling and scrolling. Terraform is like the number one stuff. Okay, so what's your rundown? For contract inside 35, 650 a day, blah, blah, blah. And you see that Kubernetes, Terraform, CI/CD pipeline, and all the rest of it. Okay. It's just to show us that Terraform is quite the number one leader. And that's what we're going to learn. So we're going to learn how to use Terraform, essentially to provision our infrastructure. And so what is this Terraform thing? So let's look at it. Let me take us to Terraform. So it's HashiCorp. That's the same guys, HashiCorp, Terraform. So remember that what we want to do, just so that we don't lose sight of what we're trying to do. So we've generated those images. This one, we want to start spinning up VMs. So we're going to use Terraform. And then we want to get that instance. And this as well. Okay, we'll use Terraform and to do this instance. Yeah, so that's what we want to use. So Terraform is basically all code managed infrastructure as code. And you do the install, you do the tutorials, blah blah blah. So if that was good, we start with the install. So it's all the same, same thing, same vibe, same approach. OS, Mac OS, Windows, download, blah blah blah. Because we probably will be using our tool server to kind of do all the creation and stuff, so it makes sense to have Terraform on our Linux tool server. So we're gonna copy this and we'll install Terraform here as well, our tool server. So the tool server, okay, I think because we left this for a bit, is basically frozen. So we will connect again to the tool server. Okay, so the tool server, we connect, and then we're just gonna test. We have Terraform. You see, we don't, so we install it. Okay, and then off we go. Yes. And then we'll test it again. Save version. And then we're good. You can see we have Terraform installed now. This is only 2.7. Okay. And on my machine as well, because I'm going to be writing code. So my local machine, I have Terraform as well. So it makes sense for you to have Terraform on your Windows and on the tool server you're going to use. It's not that you'll be executing Terraform implementation in your code on the repo, but you would do all the validate and stuff, init and stuff on your local machine, just to make sure that you have the code you're writing makes sense. So you want to do your validation. That's why you would need Terraform locally, not because you want to execute the Terraform code. So now let's start. So in our case, we want to deal with this Nginx one first. Okay, this is the AMI. So if you were creating a system, right? We're creating a node. Before we go to Terraform, we're creating a node. Of course, because it's EC2, we need to go and find, we need to go to AWS instance and create EC2. We go to EC2, not database. We go EC2 to go look for Elastic Compute 2, which is a VM, essentially. That's the first thing we do, right? So with EC2, obviously, there are a few things that we need to sort out as far as creating a machine is concerned. Okay, so we will say when I create an EC2, we will launch an instance. Okay, and then we'll probably give the instance a name. So we'd say give it a name, and then we'll separate the image. In our case, we want to use that image that we already created. Then we basically select from that list, blah, blah, blah. And then we would select the instance type, probably select a key. And then under security, we would select, we'll probably create a security group or select an existing one. But that security group has to be attached to the machine that we're going to need. And then we'll go from there. So the key things when you're creating a system is concerned, obviously, maybe give it a name. That's not terribly important, but it makes sense. But more importantly, you need to give it, select the AMI that you want to use. And then you want to select the instance type that you want to use. You want to give it like a security group, and then also select the key. And that is the most basic thing that you can do when it comes to creating an instance. Of course, there's more, but if you want to create the most basic system, that is what you need to, those are the things that you need to sort out. We're not going to do this manually now. We're going to use Terraform for it. So let's see what it looks like. Okay, so this is Terraform. So Terraform basic installation, we'll start with tutorial. And then this is the AWS tutorial. This is the Azure tutorial. This is the Google Code tutorial. This is Docker tutorial. Depending on what you're targeting, let me share this with you. So we'll see. So I'm gonna put that here. So we'll see it. Right. So we go to tutorial. Just click that, and then you should just go with Terraform, and then tell you a sort of things. So you can just code. You write your code. You plan it. You apply it, and then it does what it has to do for you. Okay. Um, the, let's see, and then create an instance, next step, Terraform, install, which we've done, Terraform, next step. This is a beautiful tutorial, so can literally just follow this to show you how things are done. You can see this is how you then begin to write your Terraform code, which is similar to Parker. And then you go on and on, version, create instance, the AMI you want to use, the name of the EC2 instance you want to create, the tag name you want to use, and so on and so forth. This is just the most basic machine as you're trying to create. And then on and on and on and on and on it goes. The thing about Terraform is that it is well documented. Okay, so by the way, when I say documented, it will, let me see, tutorial library. Yeah, that's fine. It's here, it's Terraform. Terraform registry. Let's see, Terraform registry, Terraform libraries. I will advise you to check this out because this thing is rich. So people also do extend Terraform to write their own Terraform code and then make it available to you to do even more complicated stuff. So there are a lot of providers, a lot of, we are going to really explore this, don't worry. And because we're going to spend a lot of time on using Terraform. So we're going to start our own journey. So we're going to kind of provision our first system. So we go back to our little code base, and then we'll probably close everything up. Let's close everything and close Packer and go to Terraform. Okay. Now we won't begin to write the Terraform code, and I'm going to help us kind of stepwise just understand it. But this is not how you're going to be writing the code going forward. So what I mean by that is what I'm going to do now is going to be super slow, but nobody writes code like this because usually you have some template, you copy and paste and just make little adjustment. But if I do that now, we will have missed out on some things that are fundamental things that we need to understand. By the way, when we get to maybe week 14, week 15, we are going to switch to using AI for writing our codes. But if we go to that straight away now, it probably is dangerous because we might miss out on the fundamental. AI make things ridiculously easy, scarily easy. And I don't want to, it's like you're a child of a rich man and it's spoiling you already. You probably won't understand life because it'll be too easy. But when we move to AI, we are going to be so surprised how easy it is to basically write code. So, but we won't start with that yet. So we would basically start writing code as if we're like old school folks, and then we'll move it from there. So this is how it starts. So we start with Terraform. It's almost like the Packer one as well. So you have to specify the version of Terraform that you want to probably use to manage your code. So you can say required version, and then you say, okay, it should not be anything less than maybe 1.6. just to make sure you're not using a very dated version. Okay, so 1.6 required version, and then provider. So remember that Terraform now required provider. In our case, now we want to use, so if it's AWS, Azure is where you specify AWS equals, and then you specify the version of the plugin of the provider you want to use. So the source is HashiCorp AWS, HashiCorp AWS, and then the version that we want to use of the plugin, not Terraform, but the plugin for AWS should be around let's say 5.0 and above. So what we are saying here is the Terraform version that you're gonna need should be around 1.6 or higher. The provider for AWS should be this or higher. Okay, and that's that one done. So, and then you then begin to specify all the credentials that system will need because you're targeting AWS, so you need to specify that the provider in this case is AWS. And then this is where you probably begin to specify a few AWS specific information, such as region. So I say AWS and then region, where you want to do the magic. You can say you want to do it EU West, West 1A. But let's not, the region is EU West 1, so it can be West 1A. So this is all basic stuff, essentially. I'm using Terraform, I'm using this plugin, and I want to be targeting AWS, and my region of interest is EU West. That's the region. And then you can begin to create the machine. So the resource we want to do is a resource we are interested in. By the way, I've installed some plugin. I'll tell us about this plugin later, but for now, let's just keep it nice and simple. So the resource I want to use is AWS instance, which is the EC2. To basically create an EC2, all you need to do is you say the resource is AWS instance. Okay, that's this resource. Let's see. By the way, I'm gonna show us something interesting here. So I'm gonna come to this later. I'm gonna finish it, but by something I want to show us. So on AWS, on Azure, on the Terraform page, there's the registry.terraform.io, and there's something called resources. I will share this. This is very, very important. In fact, let me share it now before I forget. This is very extremely important. This is where you would have access to those resources and see how they're being used. So now, if you see here now, this is documentation on how to use Terraform. So this is all the things I've been describing. And then this person is trying to create a network. So there are many resources you can create: network, storage, VMs, and stuff. Okay. Now, depending on what you want to use, in my case, now I want to create a VM. So VM creation is called AWS instance. So the name of the resource are all specific. So in this case, this resource is AWS VPC, Virtual Private Cloud. The name you give to it is just a variable name. It doesn't matter what the name you use to represent this, but this is important. This AWS VPC has a meaning to Terraform. The name you give it doesn't really hold much. You can use whatever name, but this one you can't change. It would depend on what you want to create. For example, there's something called AWS instance. It comes back. Taking too long. Okay, it's come back. AWS instance. Yeah, AWS instance. AWS instance. Just be patient. You type it, just go and do some silly search. Oh, it's taking too long. Right. But I think it's just trying to do autocomplete and it's just stuck. Okay. I think it's come back. Resource AWS. Elastic Compute 2. Yeah, that's the one. But under resource, that's the one. Resource, AWS instance. And then you will basically see how to can see AWS instance. And this is just shows you how to. So the difference between data, let's not worry about data for now. Let's just focus on resource. And I will just tell you how to play with instance. So I don't let's see instance. AWS instance. Okay. And it just shows you how to use the instance. So AWS instance, see, AWS instance, the name is this, AMI that, instance type is that, tenancy host, and the lot of options that it takes. So for example, you have specified the region, which is optional, AMI optional, address optional, and so on and so forth. Now, these are the options that go with AWS instance when you're creating it. And you're going to be seeing as we kind of create it, optional. And the thing that are important, it will tell us they are not optional. You'll see them. I think the ones that are key, they will not be represented as optional. And then you look at examples, they always give a lot of examples on how to use them. So the point I'm trying to make here is it is well documented. So you can't go wrong. And because people have been using it for a long time, you're always going to get support and so forth. So we'll start. So we are going to then go here. So we're going to create our instance. We're going to call it, let's call it, the name you call it is not terribly important. It's only used for coding purpose. So we're going to call it, let's call it Nginx, Nginx node, something like that. Okay. And then we would begin to specify the things that we need. So AMI, we are going to need instance type. We are going to need subnet ID. We are going to need the network VPC security group. Security group IDs. That is it. Group IDs. We are also going to need name for the key to use. And then, right, and then we'll probably will create some tags so that we can give it a beautiful name, maybe tags. And then we're gonna create some names. So we're gonna give it a name that you see when you log on to AWS. We can say Terraform Nginx node, something like that. Okay, so this is what we're gonna need, right? So we begin to fill this, okay? So we'll do something like this. So the instant type, we know this is to be a tier 3 micro, and the ones we know will fill now. Which group, security group should it belong to? And then which security group are we going to apply to it? This is tells us the port that's going to be open on the machine, the one that will be short. I think this is master class for me, master class 2025, which is my key. I'm going to look all this up to make sure it's correct. So let me go back. So the thing we need AMI. We want to use the new AMI for this one. So we will go, where is it? Diagrams. So this is the one. It's the one we created. Copy. And then we'll put that on here. right? Incident type is micro. The network, which data center do you want to dump it? We can go look that up, and security group will have to create that. I want to confirm the key name as well. So we go here. Okay. So I go EC2. I will go to my blah, blah, blah. I will go to my key pairs. So let me check my key. Okay, master class, uppercase M, uppercase class. I think I got it. Also, in terms of network, so if I click on instance here, I was trying to create an instance. I say launch instance. Then I want to look at the network, right? I could do something like, let's see, edit, so this is the network. I want to see the subnet I can use. So if you edit, and then you go subnet, you can see the list of subnets. So I can potentially copy this. Let's see subnet. Let me even pick that and see, because I'm not gonna use it here. I'm just gonna use it, just copy this one. I'm gonna just, can I copy it? Maybe. So I'm gonna use that subnet, which is the subnetwork where my network is gonna be based. Hope I got it. I'm not sure. I think it looks strange. Okay, so I missed the subnet in front, subnet dash. So let me put that there. I think that's probably subnet dash. I think that's it. So subnet dash, security group ID. So which security group do you want to attach to it? So you can get like a security group. Let's see. So I can use an existing security group. Security group is like all this wizard, blah, 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 that you can attach or you can create your own. So we can look at an existing security group, or we might create one on the fly. So if you wanted to use an existing one, you just need to go find it. There's so many security group, because probably this one is for engineers. It has to have port. It has to have port 22 and port 8080 enabled. Let me say maybe this one. We're gonna probably create our own, but I want to show us, you know, what we're actually trying to do. So this one probably will not work for engineering, because we need port 8080. So we have some security group that inadvertently have been created when we're creating so many machines in the past. So we can find one that we can use, or we can create our own. For example, this would work because 22 and 80. So if you wanted to kind of make things easy for yourself, you can just find an existing security group. It doesn't mean you can't create your own. Let's use this for now, and then we'll create our own later. So SG, that one, let's copy it. And I want to show us how to create our own later. I want to kind of make this super simple, and then we will see. I think, hopefully I'm right. Let's see. I think this is how you would do it. Yes, I don't want to overcomplicate it. Let's see what it is in there. Okay, cool. I want to kind of make the code small, and then we'll kind of make it bigger as we go along. So, and then, you know, this is it really. This is super simple. We are going to make things, looking at the time, I'm going to extend it a little bit, but let me just see if we can get away with just this very simple basic stuff. One thing I might want to add is when node is created, I probably want it to show me what the IP address is, so I don't begin to struggle to look for it. I probably will escape that as well for now, because I don't want this to be overly long, and then we will see that inevitably it's going to grow long, but I want to make it super simple first, and then we will extend it. I hope I'm going to succeed in my mission, because I don't want the code to be too long. So this is all done now. Essentially declaring Terraform, declaring the AWS platform we're going to use, and then Also specifying that we want to create a node and using the AMI, the subnets and security group, not the rest of it. Okay, we'll see. All right, cool. So we'll CD here, CD to Terraform. And the same thing, just the same thing, I just do a Terraform init. So initialization is done. This takes time because it will download the Terraform AWS plugin. The work that usually takes time. Um, that is basically being installed. This takes a while, sadly, to have that. So that is coming. And then the next we want to do is want to validate and then probably also format. Okay, hopefully it comes by real quick. Yeah, it's taking a while, sadly. By the way, if you let me see if I can show us a few things why this is kind of okay, it's all blocked. Okay. Really, we just need to be a bit patient. It takes a while to kind of download that stuff. It's quite hefty. Okay, okay. I think how many do we have in class today? Let me see. I'm not expecting a lot. Okay, I think we just like inevitably the class will go smaller and smaller and smaller as we go along. As things get harder, people will then find their bearing and say, "This is not for me. I'm just gonna slowly fade away." That's something almost inevitable. Okay. Da-da-da-da. And I also think because there's a football thing going on, so I think yeah, that's probably what have it look. Okay, this is still going. So I don't want to wait that long. So I will show us. So this here is here. So let me show us. So we sit into classy. Let me make it a little bit bolder. Yeah, so we'll see it better. So we go in Terraform. This is where all the magic is happening right now. As you come back, you're still thinking about it. So it's installing. I'm going to show us what is happening. So this is Terraform. If you see ls minus out here, which is show what is in. If you start put a, it then shows you something that you probably don't see with naked eye. You can see. I think it's still downloading. So we should see like a .terraform, which I have not seen here. I think it's still downloading. We should probably, let me see, find a. Okay, I think it's just taking a while. If it doesn't finish, I will just terminate it. It sadly just takes time to download that thing. and get it on. So what I'm gonna do is because I don't want to wait forever. You're gonna have to pardon me. I didn't want to, and you can see it's in my Terraform is out of it. So now it's done it. You can see there's a .terraform folder there. Okay, it's done it now. So by the way, you see that it's saying my version of Terraform is old. That's when I'm running on my machine and it's advising me to update. So I probably would need to update myself, but it doesn't really spoil anything. So, but the Terraform initialization has passed. So now something is important. There's a .terraform directory that gets created and a log file that is created. But this part is very important. When you do Terraform init, it will create a folder called the Terraform. That is where you would dump this plugin that we're talking about. That plugin gets dumped in this directory. And then there's a log file that is created for you. These are not terribly important for your work. And by the way, what I mean by that is if you do ls-ltr, you only see main file, but if you put A there and then you see the Terraform directory, it's a directory, and the log file because it's a dot, so it's an hidden file. So that's why you won't see it if you don't put all A there. Then you see it. If you go into the Terraform directory, you will see the plugin. And then you can see the provider, blah, 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 all the rest, you know, see the plugin and all the rest of it. This one doesn't really bother you. The only thing that is important here to notice for your version control system, you should not be managing this directory and this file. You should exclude it from your Terraform, from your GitHub operations. So your Git should exclude this file. It's very important. You should not be moving this file into your repo when you go do git push, git whatnot. This should all be localized to your machine. They should not be moved around. So you will gladly ignore this file when you're using Git. So when you're using Git to push, this should be ignored. I'm going to show us how to do that. But for now, so we say Terraform init. So the other thing we might want to do is we want to validate the code. Validate. Just make sure the code is clean. It's going to check it for us. And then we probably will format the code to make it look nicer. So those are the two things we want to do. Did I know? Okay, it's valid. It looks good. And then you can format as well. You can say FMT, and then it just arranges your code better for you. Okay, so everything just aligns and look good. So that's what format does. But what is more important, okay, is how you're going to manage these things. You can see now we have Parker. We're not looking at Parker now, but you can see the green ones are the new one. And the main one is one that is changed. The green is new, the main is changed. We don't want to include Terraform directory as our manage into our GitHub management. So when we push our code, we don't want to carry this along. It's an extra baggage that is security sensitive. You shouldn't be moving it around, and it's heavy because it can be generated when you need it, and this one as well. So what we do is we will create a file. File is called an ignore file. It's called git ignore. So we do a dot git ignore. So these are the list of files we want to ignore. Okay, for git ignore, if you look at this, we want to exclude .terraform. Also, we want to exclude anything .terraform .lock .hcl. So that one we don't want to include that as well. You can see now, you can see that it's changed. It's no longer tracked. The Git is no longer tracking them. You can see the colors change because we said, okay, they should be ignored. So Git is no longer targeting them. So when you do your Git copy, Git push and stuff, this will not be carried. So this is very important. So we are saying exclude that folder and exclude that file. And that's why we create the Git ignore file. So we then say Git add all. We'll say Git status, see us what we're going to be carrying around. So we can, let me go back one step. So I can add the Git ignore file. Let's say Git status. So these are the file I'm going to push, which is good. I'm happy. Then you commit, git commit. Add in Terraform code, publish, and then it's gone. And then I'll go here and this machine. If I can find it's frozen, I'm just gonna close it. I'm gonna just get, okay, instance connect. Connect. Okay, now we are going to then WD, we go back to our workspace. In the workspace, we have that classic stuff. So we can either delete that and create a new one, or we can just simply walk into it and do a pull. That should give us everything. You see the Terraform ignore file, Terraform name, blah, blah, blah. The ls, we're gonna see Terraform. Okay, and then we have the file. So what we need to do is basically we can do our init, or we can do our validate as normal. As I said, the init will take time again because we're on a server now, Terraform init. We're no longer on the machine, so this will also happen as it should. It will take a while to do the init. And that comes back after a while. We'll do the init, we will do the validate just to check. Okay, and then we do validate Terraform. Validate. Okay, and this is good. And just to check that is good, we don't need to do any format. And then we want to plan. So plan is the system will tell you what it's going to do without actually doing it. The plan is look at the code, go to AWS platform, check what we have there, and see how this code impacts the AWS platform, our platform. So you know we have the code, which is create EC2 and stuff. So this is the code. It's very, I try to make it super simple. Inevitably, it's going to get complicated later. But in this case, we just say, okay, look at the code. So this Terraform will look at this code and it will connect to AWS platform and see, oh, this is what I want to do. This is what's going to happen. That's what plan does. But before he's able to look at your infrastructure estate and then compare that to what you have in the code, it needs to be able to authenticate to AWS. Currently now, because we just opened this new console, the export we've done is gone. So if we say plan to show us what it's going to do, which will require to connect to AWS platform, plan will fail. So, but we're going to attempt it anyway. And then we'll then provide it what it needs to do proper planning. Set up on plan. And then I expect this to fail. Okay, just saying I don't have the credentials. I need it to be able to do my work. Give me my credentials. So we're gonna kind of provide it what it needs. Let me see if I can get those credentials. Please bear with me. Okay, I got them. Okay, it's just normal export again. Export that. Export this. And the region as well. And then I think, and then, yeah, that's all we need. And then we'll do a plan now, and then it's going to tell us what it's going to do. If hopefully the code is correct, I try to kind of make it simple. Okay, cool. Now this is what it's going to do. So it's going to say plan is to Basically want to add, nothing to change, nothing to destroy. Sometimes you might find something that already existing needs to delete before you create a new one, because sometimes maybe you create a machine and you want to change something, you might tell you I can't change it. I need to delete the machine and then create a new one. That's a destruction, a destroy. But in this case, there's nothing existing that it needs to destroy. So zero destroy, nothing to change, but we're going to be adding one thing. So what is it going to add? And this is what it's going to do. I am going to create a machine with this AMI. I am going to use all this there. I'm going to connect to this subnet. I'm going to give it this name, blah, blah, blah. I'm going to use the security group and so on and so forth. That's what it's going to do. If you're happy, you just say, yes, I like that. Apply, please. And then it's going to start doing the work. Now it's going to tell you again, this is what I want to do. Are you sure you want to go ahead? And that's the difference between plan and apply. So apply this, yeah, I'm going to go ahead now. You want to go ahead and you say yes, and then it begins to build the system. So if we go here now, we should see it in action. There we go, instances. Let's see now Terraform Nginx node that's being created in file. Let's check if it's accessible. You'll see, connect. Is it ready? I'm just rushing. Let me use EC2 user. Let's use that. And let me see if we can connect to it. Yep, we connect to it. And also, because you should be running Nginx, because of the image that we use, we'll probably, okay, let's look at this. So this is Terraform application done. So apply is done, and that's that there. And then also, if we look here and we get the IP address of the public DNS, let's see if it's got Nginx, which obviously what we prepared yesterday. Let's see if that's sort of also working. HTTP. And that, if it works well, yeah, it's all good. So I've tried to kind of minimize the code. We've cheated a little bit. I'm going to show you where we've cheated. So this is Terraform. We've applied it. It's all cool. It's good, right? So if we inspect the code just for a second, we go in here and look at the main code. Yeah, so this is all fine. This is all in order. Okay, the AMI, yes, this is the one that has Nginx in it. The instance type is good. This is okay, but this is cheating because now you have to manually. We are trying to avoid manual creation, right? But this is something that we may have created manually, which is security group. And then because that was already existing, if you use this code now, in your case, it won't work because the security group is basically tied to my instance, and this probably tied to my instance. This is tied to my instance. All this you might have to replace. You can create your own security group on the fly instead of using the existing one. It's just telling Terraform to create that security group for you instead of using the one that already exists. You can just create your own and then specify the port that you need. If you cannot do that, you can manually, for now, create your security group as I've done here. I'm using an existing one that has port 80 and port 22 open. Let me go back here. So I've got so many existing security groups. It's just crazy. I looked for one that has port 80 and 22, and that's the one I used because I need 22 for SSH, 80 for the web. So if you were doing one for Java, if you're going to be running that Java code on it, you have to maybe create your own and just create that security group. If you don't know how to use Terraform to do it, because I haven't shown you, one thing might be to create it manually and then leverage it in your code. Yeah, we're going to look at how we're going to create all this in subsequent classes. So, which is obviously here, and then you can just manually create it and just reference it in. Open the port you need to open, create it, and then use it. And then with that, you can then create your instance. I try to make the code small, so we see that even with little code, you can do a lot. And this name here is the name the instance will bear when it's created. And that's it. So if you're done with the instance, you can go and, wow, you can go and destroy the instance. Apologies, I just got distracted. I think Nigeria has just been kicked out of this World Cup qualifiers. Okay. All right, Terraform destroy, just to remove the instance completely, and just say destroy. Will be deleting that instance. And it's gonna say, okay, are you sure you want to do this? I'm gonna do all this. When all this is done, I'll have one instance destroyed. Are you happy? You say yes, and then it begins to clean up the instance. So while that is going, I'm just gonna show us what I want us to do for our next project. If you want to crack on before I send it out, but this is what it's gonna be. So it's gonna be our last project essentially, but now with a twist. So we've learned about Terraform, and we've learned about Parker, right? So both. So Parker to create an image, Terraform to instantiate the image. All right, so this is Terraform. This is Parker to create an image, and Terraform to basically leverage the image and use it. Okay. So what I want us to do for this week is to, depending on how good your knowledge is, obviously the people's attempts or approach will be different depending on how much you know, but everybody should attempt it. So the idea is that we're going to go back to this vegetable market thing again, but we're going to do what we did last week. But now the only difference is let's create this Apache web server, use Spark to create the image, and then use Terraform to instantiate the image. This also Parker for this to create the image, and Terraform to instantiate the image. So we'll probably end up with 2 nodes. The security group, if you don't know how to use Terraform for it, you can manually create port 80 and 22 and attach it to your Terraform. And then port, all the ports, I think it's port 8080 and 9000 for your Python and Java. So we can see now the work we are doing is gonna be, inevitably is gonna get, a little bit more interesting as we kind of go along. So it's the same project, but now using Packer and Terraform for your creation. So I want to see your code, and yeah, so that's what we're gonna do for this. I will provide that, release it as normal, but that is what we're doing. So officially, I will probably set it out tomorrow. But that is what it's going to be for this week. So any questions or comments before we wrap up? Okay, all right, no question, no comment. Thank you, guys. Have a good one. I will share the video, and as normal, have a blessed week ahead. Thank you.
Thank you.